Section 2.4, guys, is going to cover multiplication and division. Why can they put it in one section? The exact same rules, all right? So the whole idea here is these rules that are up here with this little sun. When we go to the division ones, it's going to be the same thing. Anytime you take the product of two numbers that have the same sign, they always end up being positive. So we already know when you multiply a positive times a positive, it's positive. But what's new to you now is two negatives make a positive, okay? When we multiply two negatives, they counteract each other and make a positive. Over here, the product of two numbers that have different signs is always a negative number, okay? So it doesn't matter which one's first, which one's bigger, it doesn't matter, okay? If you have a negative and a positive, the answer is negative. That's the same for division. Yes, ma'am?
Got an easier way.
Yes, tell me.
It's like a triangle.
Can you come draw it up there? If I give you a marker?
Yeah.
Sorry, recording. You're not going to see this. I want to see it. This is awesome.
The plus, then the negative. So you got put a plus and a minus sign. You know that it's a negative. Then you got two negatives. Then it's a plus.
You guys see that?
Yeah.
So whatever you're multiplying, cover it up, and the remaining sign will be your answer, okay? And the reason why we don't need a plus and a plus is we already know multiplying two positives is a positive. Thanks, Bree. That's perfect. Okay, I'm going to put that on here just so if anybody is watching. Does anybody watch my videos? Maybe someday. I'm on YouTube. Isn't that cool? Okay. So if you're multiplying a positive and a negative, you cover it up, and what the answer is a negative. If you're multiplying a positive and a negative, you cover it up, the answer is a negative. But if you're multiplying two negatives, the answer is a positive. Okay? And you already know positive times a positive. And the proof behind it's kind of cool because when you do multiplication, it's just repeated addition. All right? So if you're adding a negative over and over and over again, you're still negative. All right? And that's just the whole idea behind it. So it will go pretty quickly because they're going to just give you kind of just the basic multiplication factors. We just have to remember we can still do the repeated addition if we need to, the tally marks your fingers. But once you get your answer, ask yourself what the sign will be. Or decide the sign from the beginning, either or. Sometimes I decide the sign from the beginning, type it in my math lab box, and then I worry about the numbers, okay? So for example, let's just talk about this. What's a negative times a positive? A negative. So I'm just going to write that. What's 3 times 8? 24. So what's our answer? You got it. So this is what I would do. I would just figure out the sign and type it into my math lab. So if it's a negative, I'm typing in a negative. If it's a positive, I'll leave it alone. And then I worry about the product, 3 times 8. What is negative times a negative? Positive. Okay. What's 5 times 2? 10. There's your answer. What is 0 times any number? 0. What is a positive times a negative? Negative. What is 5 times 10? 50, and we're going to put a negative there because our answer is negative. Everybody knows a rule about multiplying by 10. Just add a 0 to it. Okay. All right, so they're like, great job. If I give you 2, it's no big deal. But what happens if, I feel like I'm really close. We start getting a lot in a row, just move left to right, okay? So when we do this, we have a positive times a negative. What's that answer going to be? Negative. What's 8 times 6? 48. So now we have negative 48 times a negative 2. What's a negative times a negative? Positive. So now I'm not even worried about my sign. What I'm going to do is go over here and do 48 times 2. 2 times 8 is 16. Carry my 1. 2 times 4 is 8 plus 1, 96.
Does it matter what order we did it in? Because I did like 6 times, like negative 6 times 2.
It doesn't. So what she's noticing shortcuts. She knows that 2 negatives make a positive. Right there off the bat, if you can get rid of your negatives, then you have all the positives. When it's all straight multiplication, order does not matter, okay? When you start throwing in division and addition and stuff, order will matter because it's PEMDAS. But if it's all multiplication, you can pair up anything you want, all right? Negative 9 times negative 2 will give you a positive 18. But then what are we multiplying by? A negative. So we know the answer will be negative, but what's 18 times 1? Just 18. So our answer is negative 18. Isn't this easier than subtraction? That's what I told you. Like, and that's usually not the truth. Usually multiplication and division are the harder. All right, I'm going to use Mariah's kind of little trick. What do we know about pairing up two negatives? It'll be a positive. What do we know about pairing up two negatives? Positive. So what do we know about our total answer? Positive, okay? So right there off the bat, I kind of took care of my signs, and so then it's not as overwhelming, and you can just do the multiplication, okay? You can do any kind of order. Maybe you like 4 times 5 because it's 20, and then 20 times 3. It doesn't matter, okay? I'm really systematic, so I always go left to right. What's 3 times 4? 12. And then what's negative 5 times 1? 5. And then do you guys know your 12 times table? It is 60, okay? If you didn't know that, just throw 12 times 5 over here, okay? 2 times 5 is 10, carry your 1. 5 times 1 is 5, plus 1 is 6. So 60 there. All right, so this is important. So make sure you pay attention to this, because what we do in example 8 and then what we turn around and do in example 9 look very similar but have 2 totally different answers, okay? On the end of chapter 1, we learned about exponents. What's this little 2 mean? We're going to the second power, right? So we're going to times it by itself twice. But what do we times itself? What is the number that is squared? Negative 5. So we rewrite this as negative 5 times negative 5. Why do I know the negative's part of it? Because it's in that parentheses that's being squared. What do we know about a negative times a negative? Positive. And what's 5 times 5? 25. So your answer is actually positive 25 because you have a negative times a negative. Why am I pointing this out? Because on the top of page 2, there's something different happening. What's different from what you see on top of page 2 compared to this one? No parentheses. Exactly. You're like, well, why does that make a difference? Because since there was parentheses, this means I'm squaring all of it, the negative 5. Here, though, it's got like 8 pages. You're only squaring the 7. And who's hanging out the whole time? The negative. So we're going to have a negative, and then we have 7 times 7. So I'm going to write no parentheses. So that just means square 7 and give me its opposite, right? So what's 7 times 7? 49. But what's the opposite of 49? Negative 49. Anytime you have an even power and the negative is in the parentheses, you'll have a positive answer because you have a bunch of pairs of negatives that will cancel out. But the second you have an even power and there's no parentheses, it just says square it. Just square it like normal, and this negative just hangs out. Okay? Because this little 2 only goes with what's directly to the left, and the only thing that's directly to the left is that 7. Where if you look at the bottom of page 1, what's directly to the left? The parentheses. And what's in the parentheses? All of it, the negative and the 5. Okay? So I'll try to point that out as much as possible. That's multiplication. Can you handle it? Guess what? Division's the exact same, okay? And what's nice about this division is that it's not even long division. It's just going to be normal division, and look at the rules. They're exactly the same. The quotient means the answer of a division problem, okay? The quotient of 2 numbers having the same sign is a positive number. So a positive divided by a positive is positive. A negative divided by a negative is positive. Negative divided by a positive is negative, and a positive divided by a negative. Again, it doesn't matter the order, it doesn't matter the size, they're both negative. Bree's triangle will still work for division, okay? So here are just a bunch of different ways we can show division. Let's worry about the sign. What's our sign going to be? Negative. And what's 42 divided by 7? 6. What is a negative divided by a negative? Positive. What's 16 divided by 2? 8. What's a negative divided by a positive? Negative. What is 80 divided by 10? 8, right? The zeros kind of cancel each other out. All right. Look what we have coming back to haunt us. Oh, yes, thank you. I write negative here, and then I just put an 8 there. Thank you. So we have 2 versions, 10 and 12, of a positive and a negative, but notice it doesn't matter which one's on top, which one's on bottom. The answer is negative, all right? So we know with division of 0, one answer is 0, and the other one's undefined. Which one is which?
13
13 is
is undefined.
undefined. Because how do you say 13? -6 divided by 0. You cannot divide by 0. So this is -6 divided by 0. This is the dreaded words you cannot say, right? So this is undefined. But can you take 0 divided by 7? Can you divide by 7? Yeah, we just did it right up here, right? That's okay. So what's 0 divided by -7? Just 0. The dreaded words, divided by 0. Divided by 0. It cannot happen. All right, so now we can do number 18 on our yellow worksheet, but I won't have us do it. If you look at number 18 on your yellow worksheet, it had you multiplying positives and negatives. We didn't technically know it yet, right? But on example 15, guys, we're going to just be doing what we've been doing since like 1.6, where they'll give us variables, and we're going to plug in variables. What operation are we going to be doing since these variables are just shoved right next to each other? Multiplication. So we're going to, and this is, now that we're with negatives, when I plug them in, guys, I'm going to be putting parentheses like around everything. So we have 5 times -8 like that. Is that okay? If you want to put the times symbol in there, you can. It's up to you. What's that answer going to be? Why is it negative? It's a positive and a negative. So again, this is negative because we have opposite signs there, and it's going to be 40 because 5 times 8 is 40. Is that okay, guys? Not going too quickly? Let me know. And like I said, if you're like, oh, I don't want to say it right now, call me over when you're working on your worksheet there. All right, 16 is the same idea, but now it's just with division. X divided by y. What do they want us to make x? -12. What do they want us to make y? -3. What's a negative divided by a negative? Positive. What's a 12 divided by a 3? 4. So you guys see how we're just taking this exact same expression and plugging in the numbers they want us to plug in. Any questions there? All right, so you kind of see a pattern with these sections. They introduce the topic, we do a handful, we make them more complicated, but then we always end kind of with a word problem. And so on 17, it says, a card player has a score of -13 for each of 4 games. Find the total score. So the total score makes you think you have to add, and you can't. You can do -13 plus -13 4 times. Or remember, whenever they give you one scenario and then they turn it into multiple, it's multiplication. So he had -13 for 4 games. That's how I would do it. I mean, you can add -13 4 times if you want. Let's focus on the sign. What's a negative times a positive? Negative, and then 13 over times 4. I'm going to go over here to the side because I don't have it memorized. Bless you. 4 times 3 is 12. Carry your 1. 4 times 1 is 4 plus 1 is 5. Did you guys get 52? And remember, the reason why this works is because multiplication is repeated addition. So if you did -13 plus -13 plus -13 plus -13, you get -52. That one doesn't really have a unit. Maybe score of or something. I don't know. Total score, yeah, something like that.